Now I had an introduction and a bio for David Drai, but he's very happy to introduce himself. So I give to you, David Drai, CEO of Anodot.
Hi everybody. Thank you very much for hosting me here. It's a great pleasure. It's my first 3 days in Australia, so I'm really excited. People here are really great, I have to say. During the trip, my machine learning worked, my human machine learning. So I learned a few things about Australia. I learned that everyone here is called mate, unlike other countries where people have names. I learned that if you want to turn off the light, actually you need to turn on the light. And when I was in the hotel, I wanted to open the door. I used my reinforcement learning, and I closed the door again and again and again, but at the end I found a way to open the door on the opposite way. So, great country. Thank you very much. So I will talk a little bit about my past and the way that actually, what was the motivation to create this company, to create Anodot. Before Anodot, I had another startup, a CDN startup. CDN, if people don't know, it's content delivery network. It's accelerating content over the networks, nothing around the data scientists. However, we collected huge amount of data. After that, I sold this company to Akamai for a decent amount of money, which allowed me to take a bit break for a year. So half of my day I was surfing, not in the internet. And half of the day I was asked from a company called GetTaxi. It's the parallel to Uber. To work there as a CEO. So I took the job. I was CTO in part-time. It was the best job that I could ask for. And during that time, I was in charge of the DevOps, the business, the BI team. So I used a lot of tools like Tableau, Click, and so on. With all of that, with all the fact that I was collecting so much data, so much business, in one of the cases I remember that one of the telco in London blocked our SMS messages, so we couldn't get the code for new registered users, okay? Now, it's a small issue, but this small issue, with the time, what happened is that new people could not register to the application. There was a slow drop, slow leak in the number of new registered users. And after a few weeks, you identify that there is a drop in revenues. Now you try to understand what is happening, right? And after you investigate the data again and again and again, you look into the dashboards, you try to understand what is happening. We found out that issue that we just needed to change the API to the telco, and that's it. And this was the aha moment that I said, something is broken here. It doesn't make sense that I'm monitoring all my machines, all my CPU. The CPU is not 100% great, so what? What happened with the business? What happened? How I track actually my business? And visualization doesn't work good enough. So I met at the time Ira Cohen. This is actually the first message 5 years ago when we created the company. Ira was the chief data scientist at HP. And I asked him if it's doable, if he can solve it, if he can find what is happening in all the data without me to follow every morning around after dashboards and after visualization stuff. He told me that yes, it's possible. I was crazy enough to believe it. And we raised money. At the beginning, what we developed, I would say, didn't work so well. Why? Because you talked about data scientists. There is a gap in many times between what data scientists think that it's important or interesting and what is the business thinking about important. So we developed an anomaly detection, and Ira came to me and said, hey, look, great anomalies we catch here. I told him, listen, this is not interesting. I mean, what do I care that now my latency increased by 2 milliseconds? He said, but look, mathematically, this is an anomaly. And I'm saying, no, this is not interesting. So we debate a lot. And Ira is not easy guy to debate with. He's very smart. But after feedback back and forth, we understood that there is a layer that is missing, actually. The layer between the AI, the machine learning, and the business context. Okay? So what we did, we actually developed a product that is, I will call it semi-automatic, right? Think about autonomous car, right? That people are talking about autonomous car that will take you everywhere, right? But when you go into that car in the future, you will not be able to know where do you want to go. You will need to tell him where do you want to go. He will not read your mind, right? So this is I will say this is the idea. The idea is that we developed a product that customer will tell us what is important for them. And what is important for every individual is totally different. You can be very sensitive that you want to know everything that is going on from the small peaks or drops, and you can be more tolerant. It's also depends on the human being itself. So the idea of developing something that is pure AI is, first of all, to build a layer that is able to understand everything, and then on top of that, to connect to the human being. Because without the human being, it's impossible to understand what is important, and then you have the number one enemy of the AI, is the false positive. False positive is the number one enemy that then you cannot handle it without a feedback from the user itself. So, my problem, my personal problem that I had in Get Taxi was not only my own challenge, and this is why actually I decided to create this company. And if you will see in many reports, you will see that the data, of course, is growing exponentially. Needless to say, everyone is moving to data lake. And I was only with a meeting with Sham here that there was a sticker with a person that it's written there, if you say the word data lake, I will shoot you. So I was very careful at that meeting. Yeah, so people are collecting a lot of data. Companies are collecting a lot of data. Data lake becomes more and more commodity in the world. But, however, still you see many companies that are focusing on VBI, visual BI. And there is a limit to expect from human being to understand what's happening with visualization and with dashboard. And then you are left with 99% of your data that is untapped. And this is where actually Anodot is playing the game. Now, in that game, you will see a lot of in-house tools, in-house solutions. Some of them doesn't scale with the time. We see in our company many times that we replace existing solution, and some of them work very well. in this part, in this 99%, you will see a lot of companies that are playing in a market that is called augmented analytics. Okay, I don't like this word. This is a Gartner word. I prefer to use AI analytics or what we call autonomous analytics. But as you understand, there is a new wave of BI that become commoditized in the visualization space. You probably saw that Tableau was acquired by Salesforce. Looker was acquired by Google. And you will see more and more acquisition over the visual BI market. And on the other side, you will see a lot of BI visualization market that will look for AI solutions. And they will try to M&A, acquire, whatever, all kind, or develop in-house AI solutions. But we need to understand that AI is not magic. Even the champion, the machine that is the champion in Go that won the world championship, if it will play checkers with my 10 years old daughter, probably it will lose. It will lose the game. And AI needs always to be sticked with use cases. Without use cases, this is extremely difficult to understand. AI is not the goal. AI is not the goal. The goal is how to improve your business. And if you can improve your business with AI, great. If you can improve it with more simple way, even greater. Okay? So the idea is not to find or to look for any solution. Let's put a machine learning, a deep learning, whatever, to, in Israel we say, to kill a mosquito with a missile. This is not the idea. The idea is to find the right solution for the right business pain. In our case, what we took a common denominator of many companies. We are now 5 years in the market. We have companies from banks, from telcos, Atlassian. We have a few people here from Atlassian. Hi, and Facebook, and all of those had, I will say, the common denominator problem that we came in order to solve them. It doesn't mean that we solve everything. We are solving things that are around finding a business incident and finding business opportunity. That's it. Now, what we have done in Anodot, we have took data from any data source. And one of the challenges that when you want to learn data in an agnostic way, like we are doing when we measure the bandwidth of the telcos or the revenues of or transaction of a bank or users or active users of Atlassian or so, what you need to do is to find a common representation of the data that can match all of them in order to find insight from many sort of KPI. Someone has an idea, except Atlassian, what can be this data representation? Okay, so the data representation that actually is the one that can contribute to all of them in the same way is time series. Okay, time series is a way to represent data from temperature to revenues to errors in the same axis over time. And most of the things that we are measuring are time-based. It means that it doesn't matter if your data now is in tables with a timestamp or logs with a timestamp. You can convert all of them into time series. You will see many open source around time series database, like InfluxDB, like Graphite, if someone is familiar with. And what we took the same concept of time series database. However, we put machine learning on top of that. And in order to understand now your business, the vision of Anodot, or the vision of you, even without Anodot, to understand the business in a more effective way, is to have a machine learning that should answer use cases, or answer the questions. The first question is, what is happening? What is happening in my data? We saw the 99% of the data that is untapped. What is happening there? So first of all, we want to know what is happening. So in order to know what is happening, we need to understand what is the normal behavior of the data, what is usually happening, and we want to know only when something is abnormal, right? So this is one challenge. The next challenge is to understand where it's happening and why. Because after you understand what is happening, like my drop in revenues at GetTaxi, I want to know where and why. So I want to know that it was in London, and I want to know that there was a lot of rejection from a telco and a drop in registered users. And I want to see everything in one story. And therefore, the next step of the machine learning is the correlation and the root cause analysis. Okay? Those elements, I don't know, I saw that there are many IT people here. How many of you heard about AIOps? Nobody? Or people are shy? 1, 2, 3. Okay, AIOps becomes, let's say, a myth that all the IT can be solved automatically without human touch, with AI, and then to do automatic remediation. You will see a lot of companies are talking about that, but under the hood, nothing. No machine learning, no remediation, nothing. And AIOps is complicated. Why it's complicated? It's very similar to the concept of BI ops, okay, the business. Actually, it's a subset of this idea. So the idea of what is happening, where and why is actually for all your data. It doesn't matter if your data is IT or business or application. You want to know what, where, and why in all your data. And then with the correlation, you want to get a top-down approach or a top-down visibility of what is happening in your business. The next step, this is something that currently we are not doing, but part of the vision, is to do something. To do something, to do the action. Theoretically, if you can run your business alone, self-service, automated business that close the loop, understand what is happening, why it's happening, and then closing the loop to do the action for that, this can be amazing. Actually, you can rest maybe. But in my perspective, you can do that, but you can do that on specific use cases. And with the time, you will see in the market, and this is what I believe, that you will see more and more automatic action that are taken in order for you to do other actions. It doesn't mean that all your business can be running autonomously, but it means that a significant portion can be run autonomously, and in that way, you can be more effective with your business. The other element is actually more advanced, is also what will happen, okay, is forecasting, okay? If you take, for example, your company and you want to see what will be your capacity in the next month, how much hardware I need to buy, how many people I need to allocate for my supporting. A question like that can be solved with what will happen, and the next, even more complicated, is what will happen if. Think about marketing campaign. how much money I will create if I allocate this amount of money in my marketing cost. All of that can be solved. It's solvable. It's not something that is science fiction. And it will be there with the time. We are just at the beginning of the AI revolution. So at Anodot, what we did, we provide part of those questions, or most of those questions, with two services. One of them is the autonomous detection that is answering the what, where, and why. And the autonomous forecast to answer the what will happen. And the whole vision around Anodot is to provide this new innovative approach of AI analytics in a way that you don't need to be a data scientist in order to use it. You can be a marketing person, you can be R&D, data analyst, everyone can actually get insight from his own need. Few use cases. Take, for example, a taxi company that is looking at all the thousands of dashboards. Everything is great. The CPU are great. The bandwidth are great. However, this lady is waiting in the rain in Nashville because there is not enough taxis there. Is it a business incident? Yes, this is a business incident because the quality of service of your product has been damaged without you knowing that, actually. Let's see this in the data. You can see how the shaded area here is actually the normal behavior that we learn over time. And then you can see the spike in driver utilization in Nashville. And you can see what is the wait time in Nashville at that point. So with the machine learning, you actually can understand what is happening and immediately increase the driver incentive in order to bring new drivers to the road. Another example, price glitch. Price glitch is a very common issue with e-commerce. I'm sure that many people are happy from those price glitches. And then they are so happy that they share it also in Facebook and Twitter and Instagram and so on. And how it is translated into the data. You will see a high spike in the number of brand social mention, right? So you are very happy. Then you will see a high spike in new visitor, you're still happy. And then you will see an increase in number of sessions, you're still happy. But once you will see that drop in the average pricing and revenues, I'm not sure that you are so happy. The next part that we talked about is the forecast. Let's see a few use cases in forecast because this is, I would say, very interesting use cases that I saw when I meet a lot of prospects and customers. One of them is retail. Think about SKUs, stock, inventory. How many times you want to buy something and you get out of stock? It's a pure loss of business. But the trade-off is a lot of stock, then after that you are losing money if you are left with stock. So this trade-off can be solved with forecast much better than just guessing how many pants I need to put in my inventory. The next very interesting use case that currently we have customers around that is forecasting how many withdrawals he have in every countries in order to estimate how much local currency you need to allocate in every country. The more you put local currency, you are exposed to the local currency. The less you put, you hurt the quality of the service of people that cannot withdraw money. So this is another use case of forecast, very interesting use case. I can tell you that here we had a very interesting session. First of all, when we went there, forecast is a quite new service that we have. When we went to this company, they wanted 95% forecast prediction, okay? We worked very hard. We arrived to 88, 90%. And then they say, no, 95. So after a few sessions, I asked them, okay, can you give me what is your current numbers so we can compare apple to apple? And what we saw is that only for one country, we forecast better than them by more than 80%. So actually, with the 88%, the human there forecasted in around 10% or something like that, even more negative. And then the amount of money that we saved them from this specific country was $900,000 of exposure of the local currency. Now, you will say, great, I mean, we prove and let's put it in production. But then there is the psychology effect. The psychology effect is the same effect that you will not fly in a self-pilot airplane, and you will not drive immediately until you see that your neighbor is driving autonomous car, right? The psychology effect is one of the effects that we need to educate the market, and it takes time. This is an evolution. And people were actually afraid to rely on our numbers, although we show them that we are better. And this is a process that now we are doing, and now, of course, they are very happy, and the Treasury Department there is relying on our numbers. Many other use cases like capacity plan, resource planning. If I know what will be my revenues in my company, how many people I need to hire in every department, and so on. So Anodot is using also Anodot. One of the most, I will say, use cases that are more common with data scientists is MLOps. MLOps is a new terminology, relative new, that says, I want to monitor my machine learning. If I have now thousands of models in production, one of the challenge of those models is that they need to be adaptive. If I'm changing their source code, I need to make sure that I didn't break anything. And for that, actually, we can show and analyze the input and output and show all kinds of anomalies that happen there. And this is what we are doing in-house. We are also monitoring our business. We monitor the number of anomalies that we create per customers, number of feedbacks, active users. I personally connect my Anodot to Salesforce to understand how many leads I create from Facebook, from LinkedIn, paid ad, and if I see a drop, maybe there is an ETL issue, maybe we don't spend enough, or we don't convert good enough, and so on. So again, the machine learning helps us to provide more visibility on the 99% of the data that I have mentioned at the first slide. I like this slide because it represents the psychology feeling that people are getting, that they are getting things proactively without looking again and again and again into dashboards. So what is needed in order to have a company that is full mature on AI, on AI transformation? First of all, you need to map all your use cases. It's very important, crucial. All the use cases that can affect your business, of course, you need to prioritize them. You need to try to estimate how much revenues I can save with that. You need to show it to your manager or so, and to try to tackle them one by one. After that, a must-have is a strong, solid data ecosystem. Without the data, it's useless. Without a clean data, it's useless. So you need to have, of course, data engineers and so on in order to provide a data lake or any other system that can bring you the data into a maturity level. The next part is to map what are the tools in the market. You can see tools like Data Robot that is doing bricks like modules that you can run on machine learning, Python, R, whatever, products like Anodot and others. You need to map them and to see, okay, what is the right tools for every use case. And then, very important is that it needs to be part of your workflow, and don't try to educate all the company to a new way of working. This is this tend to fail, and everything should be practical. We talked about data scientists. One of the things that I'm very, I will say, strict is that our data scientists will develop only stuff that will be in production. So we analyze all the time why you are developing that algorithm, how it will be translated to production. They understand also the development platform and architecture. Every data scientist that we have is hands-on in terms of the ability to put his algorithm in the production. Otherwise, you will left with a lot of very nice algorithm in GitHub. That's it. And the last part is, of course, culture and organization and session, like this session, which is amazing, to talk and to educate more why the AI can improve the business operation of your company. I can tell you that there are some researchers that are talking about companies that are full AI oriented inside can improve their margin by 10 to 15%. This is a lot. And the competition is always progressing. I can tell you that I saw banks and insurance companies and telcos that are at this level of AI and very effective, and others that are way, way beyond. And this is a competitive edge that those companies has. That's it. So yes, the price of the light is less than the cost of the darkness. Thank you very much. Questions? Yes.
So one of the things I'm sure you're aware of is in data center context, one of the problems you have is...
Data center?
In data centers,
yes.
large infrastructure.
Yes.
If something goes wrong in one area, it typically triggers anomalies in multiple areas. So when you're looking at IT management, they typically drive off events, whereas you're looking at time series. But when something goes wrong, you can often have dozens or hundreds of things go at once. How do you handle root cause analysis? Do you use some equivalent of complex event processing?
Excellent question. Excellent question. I personally don't believe in causality. Okay, causality is something that if now I have a bug in a code in line number 42 and it affects now my error ratio, something like that, it's impossible to detect it. If I have an e-card that is broken now, it's almost impossible to detect it. This is why we need to differentiate between causality and root cause analysis. The approach that we took is that we correlate all of those thousands of anomalies together, but then we rely again on the human brain to understand and to try to route it to the right areas that this issue can be. For example, if now you have an issue in one of your NIC card in one of the data centers or in a router. Okay, let's take a router. If you have a router, you will see a lot of machines on these specific data centers that has, let's say, number of packet drop and increasing packet drop. And then you can, we will correlate them because we learn the behavior of the historical data. So we know that they are correlated. But then the anomalies are together as one story that says all those machines has a drop or spike in packet loss. And then you will, if you put also the router as the data, you will actually see that this router has also an increase in packet loss or any other metrics, but everything in one story. But then you will understand, your domain expertise will understand that the problem is the router, right? Another example that is very similar, because data is data. Very similar, but in let's say, e-commerce revenues. If I now have a drop in red shoes selling in London, and now I see that in many countries, I have the same drop of the same red shoes selling, and in all those countries, it came from iOS. So I understand that something is wrong with my version in iOS, especially if I know to correlate to the fact that yesterday I deployed a new version in iOS. And then I get the story. So I don't tell you that there is a bug now in the mobile app, but I will tell you all the story around it. Make sense?
Awesome talk, thanks a lot. Are you familiar with the work of Julia Pearl, UCLA?
No, sorry.
All right. Might be useful to check out, because he recently wrote a book called Book of Wine, and it was a kind of an easy introduction to the field of causal inference. And yeah, the talk, I've been thinking of an exact question for a long time. Haven't had a chance to see and play with the algorithms, but my understanding is that the theory is well developed, and the limitation to actually automate the process of understanding what it is that causes what. So the stuff that you said before, that you don't believe in full causal analysis, that it actually is possible. It's being worked out. The challenge there is the amount of data and how complicated the computations are. It's a fantastic field. Field we'd like to discuss.
The causality.
Yeah, automating that why, right? Because what is easy.
Yeah.
It's challenging.
That would be an interesting discussion that we could go down that rabbit hole.
Yeah, no, we're not going to go there now. Thanks.
No problem.
We can debate it later.
How do you decide which algorithm to put into production? Is there processing?
Very good, very good. So this is something that I told you that when I came to Australia, there was a meaning to that. When I came, I understood that everybody is called mate. So first of all, in order to have a well, robust product, you need to be, in AI, you need to be adaptive because the data is changing. Today you are in Australia, tomorrow you are in the US. Today you are in a place that you are selling products and it's very non-popular area for you and the data is very, very sparse. Tomorrow the data becomes more and more smooth because it's very popular. So the models are totally different. So what is the best practice to do that is to develop multiple models for all your scenarios, potential scenarios and scenarios, and to select. So what we developed an algorithm that selects the right model for every individual time series. Okay, so we are today analyze 200 million time series every minute. And for every time series, we are running in the background every day to understand what is the right model for each of them. Okay, and you see that sometimes they are changing over time. The same with the forecast. Forecast, is a problem that you don't see one algorithm that can save all the forecasts. I'm talking about forecasts of time series mainly. So we developed more than 50 models around forecasting that are running over the history of the data to try and understand what is the best accuracy for every model. And then we select the right model every day for every individual metric, okay? Now, even there, what is error? The definition of error is totally different between companies. In some companies, like the companies that I mentioned with the foreign currency, if now I predict lower than the actual, it's disaster for them, okay? Because of the quality of service is more important than to leave much more money. So what is the error is also a definition. So you have many factors that can affect your product to be robust enough to run in the ongoing base. Yes?
Go ahead, and then we'll have two more.
Please. Yeah, sure.
How long does it take to deploy?
To deploy our product specifically? How long it took you? So maybe I didn't mention, but an important part of having a product that do analysis is the ETL part. Let's call it the ETL part, is how easy it is to take data and to stream it into your platform. Today we are supporting more than 25, 30 data sources, Redshift, BigQuery, soon Databricks. And what we do is actually with almost a wizard, click next, we can fetch historical data, learn the norm from all the historical data, and then we are actually giving you value at day zero because you need to learn history, right? So in terms of integration, I will say that a day or two is enough in order to...
Just to add to that
yes.
as well, we run our service, we have two options. One is to run in AWS, we have an AWS Australia instance, which you can start tomorrow, for example.
Yeah.
Or we also have an on-prem instance because some customers doesn't want to send the data out to AWS, for example. So we have an on-prem system, or a Docker container that we install it within your environment.
Yeah, right.
So the on-prem takes a little bit of time. More time is because for the IT team to organize the infrastructure and all that. But from a cloud perspective, in AWS Australia, within a day.
Plug and play.
Plug and play.
Yeah.
Now, there was yourself and there was one behind you. Yes, I'll go with you first.
How do you compare your product, Anodot, as compared to, say, Splunk, which also has ML ops built in, but the ML ops in Splunk is more related to statistics than it is machine learning?
Yeah, right. So Splunk is, for people that maybe don't know what is Splunk, Splunk is a platform for logs that actually you can send all your logs into Splunk and then provide all kind of queries and dashboards and alerts, mainly static alerts. They have a little bit anomaly detection part, but I will say that it's not so great. And if I compare it to Splunk, I will say a few things. One, in Splunk, in order for you to understand what is happening in your data, you need to run queries, okay? So think about how many queries you need to run, and then you need to understand their norm behavior in order to, like you say, it's statistic, but what happens if you have a seasonal of every hour, every day, or once a week, then it becomes more complex to adapt to the normal situation, and then you are getting much more noise. This is number one. The number two is the correlation. The fact that you are querying in order to understand what is happening. You actually cannot correlate to the existing data like in time series. Time series is given from the injection, you can start to learn it, right? So first of all, it's more real time because you can learn it in the streaming of the data. And secondly, you can correlate it and to find also what we call unknown unknowns, because if you want to find unknown unknowns, you need actually theoretically to ask all the question to Splunk. And you don't ask all the question to Splunk. In time series, it's already there per permutation of your data. If you are tracking, let's say, your revenues in all the countries, and you have 50 countries, it's 50 time series. If you track now in every country 10 operating system, it's 50 by 10, it's 500 time series that you track all the time. If you need to do it with Splunk, you need to query it, right? Reactively and not proactively.
And one more.
My question relates to how much data you would be expecting to put in. So if you put in all of your time series from your business, do you then need to put in, for example, the weather? And do you need to put in all of the product launches from all your competitors and all of the price changes? And how far do you go? Because I can imagine that at some point, everything that looks like an anomaly, when you get to the root cause analysis, you might find that some proportion, maybe most of them, are just that you didn't have the data.
Right, so your question is relevant to the root cause analysis, less to the what is happening, right? Because if you want to track that now you have a drop in your revenues, you don't need the weather information, right? Because you have a drop in revenues, so you want to know about it. But if you want to know why it's happening, maybe there was a spike in the weather or raining or whatever, then you want to put your data inside.
And at that point, it's not really an anomaly anymore because you'll see that when it rains, this occurs. So it's no longer, the model will fit. So now the model's fitting, it's no longer an anomaly. When it rains, you get more demand for taxis. So it's not really.
Okay, now you are going to a more complicated area, that it's the difference between time series and events. Events are, like you say, let's say it's raining. Let's split to two. That there is the raining event and there is the temperature. Temperature is time series, raining is an event, right? In events, you can do, this is what is called regressor. So you can understand that after every event, there is this anomaly, then it doesn't become anomaly anymore, like you said, okay? But let's take a step back and understand, what do you want to achieve? Do you want to monitor your business to understand that there is now a drop in your business, right? This is what you want to achieve. Now, first of all, let's try to understand what is happening. Now, can you understand in every case why it's happening? No, you cannot. So, for example, we have customer that says, okay, now I am an e-commerce, I will fetch to you my competitor prices, like you say. If they do a campaign and drop the prices, I can correlate to the fact that now I have a drop in my revenues in the red shoes, right? So you cannot all the time understand why it's happening if you don't have the data, of course. The same with forecast. Forecast, for example, we in this company that I mentioned with the foreign currency, there was a stage where we were at 78 precision, okay, 78 accuracy, 78%. And then we asked them, what do you think can help the forecast in order to be more accurate? And we brainstorm. It's not a data science, it's a human contextual business problem. And then they say, maybe holidays. Okay, so what we did, we put all the holidays for all the countries, and per countries, we put the factor in deep learning LSTM of the holidays itself. And it increased by 12% only because of the holidays. Why? Because in holidays, people are pulling money more than in other days. So as for your question, it was excellent question and very relevant.
Fantastic. You can tell why this man has the title of CEO. Brilliant presentation. Thank you, David.
Thank you very much.